The most dangerous myth in the alternative construction community is that a shipping container can be buried to create a cheap, effective bunker. This is not a shortcut. It is a fatal misunderstanding of engineering that has led to catastrophic failures and loss of life. The structural integrity of a container is derived from its design to be stacked high in the air, not buried deep in the earth. The physics are non-negotiable. Today, we will explain the one engineering principle that turns these buried bunkers into death traps. To understand the failure, one must first understand the design. A shipping container is a semi-monocoque structure. Its strength is its skin. It is engineered to support immense vertical compressive loads at its four corner posts, allowing for stacking up to 9 units high. The corrugated steel walls are not dead weight, they are structural panels. They are designed to resist outward pressure from shifting internal cargo. The corrugations provide stiffness against forces pushing from the inside out. When this structure is placed underground, it is subjected to a set of forces for which it has zero design consideration. The Earth exerts a relentless, continuous lateral geotechnical pressure, a crushing force pushing from the outside in. This is compounded by hydrostatic pressure from groundwater, which can dramatically multiply the load on the walls. The container is now in a fight it was never meant to be in. This leads to the inevitable mechanism of failure: buckling. Consider an empty aluminum soda can. It can support the weight of a person standing on it, an impressive feat of vertical compressive strength. However, the slightest pressure from the side will cause its thin walls to buckle and collapse catastrophically. The long, unbraced, corrugated walls of a shipping container behave in exactly the same way. They have no internal frame to resist the constant, inward pressure of the surrounding soil. The failure begins as a slow, inward bowing of the long walls. As the steel deforms, it loses its engineered stiffness, and the process accelerates. This leads to seam failure, rapid water intrusion, and ultimately a complete structural collapse. This is not a matter of if, but when. The container's vertical strength is irrelevant. Its weakness to lateral buckling is absolute. A safe subterranean structure is not a buried box. It is an engineered retaining system. To use a container in this application, it must be treated not as the structure itself, but as a simple waterproof liner inside a much larger, purpose-built structure. The professional engineering solution involves several non-negotiable modifications. First, external reinforcement. A heavy steel exoskeleton of I-beams or tube steel ribs must be welded to the exterior of the container. This new frame is what actually fights the inward soil pressure. Second, concrete reinforcement. The most robust solution involves encasing the container in a thick, steel-reinforced concrete shell. In this application, the container is essentially just the formwork and waterproof membrane for a traditional underground bunker. Third, active water management. An extensive drainage system, including French drains and sump pumps, is required to relieve the immense hydrostatic pressure that will inevitably build up against the walls. The myth is that you are burying a bunker. The reality is that to do this safely, you must first build a bunker and then place the container inside it. A shipping container is not a structure. It is a component in a system. Its structural integrity is entirely dependent on the context in which it is placed. The container is not the bunker. The earth is the load. Engineering is not a matter of opinion. It is a matter of physics.